All right, so today we're going to look at a math problem that's so simple a kid could explain it to you, but it's so incredibly hard that it's stumped the smartest people on the planet for almost 100 years. This thing isn't just a puzzle, you know? It's a real mystery that kind of pushes the limits of what we even understand about math.
I mean, that quote really says it all, doesn't it? This problem is famous for being, well, dangerous. It's like a siren's call, pulling in brilliant minds who spend years, sometimes their whole careers, chasing an answer. So what exactly are the rules to this infamous game?
To really get what's going on, we need to lay out the rules of the game. It's called the Collatz Conjecture, but a lot of people just call it the 3n+1 problem.
That's it. Seriously, those are all the rules. You just pick any whole number you can think of, and you follow these two little steps over and over and over again. Let's see how it works.
Okay, let's start with a simple one, like 7. It's odd, right? So we multiply by 3 and add 1, and we get 22. Now that's even, so we cut it in half, which gives us 11. And if you keep following the rules, the number just goes on this absolutely wild ride, jumping up, falling down, until eventually it hits 4. And from there, it's a quick slide. 4 goes to 2, and 2 goes to 1. And once you're at 1, you're basically stuck in this little 4-2-1 loop forever.
And right there, that is the heart of the mystery. The conjecture, this big idea, is that it doesn't matter what number you start with. It could be 7, it could be 27, it could be a number with 1,000,000 digits. It will always find its way down to that same 4-2-1 loop. But here's the thing, nobody on Earth has been able to prove it's true for every number.
Now, this is where things start to get really unpredictable. I mean, the paths these numbers take are so chaotic that they actually earned a pretty cool nickname.
And it's the perfect analogy, isn't it? Just like hailstones get thrown way up high in a storm cloud and then fall, then get thrown up again, these numbers shoot up to these incredible heights, then plummet back down, all seemingly at random, before they finally crash down to 1.
And to see just how chaotic it is, check this out. Take two numbers that are right next to each other, 26 and 27. The number 26, pretty boring really. It only takes 10 steps to get to 1, its highest point is 40, but its neighbor, 27, whoa, it's a completely different story. It takes 111 steps and skyrockets to a peak of over 9,000.
To put that in perspective for you, if you think of that number as an altitude in meters, the sequence for 27 climbs higher than the summit of Mount Everest. I mean, can you believe that? All before it starts its long, crazy trip back down to 1. This kind of wild volatility is exactly why the problem is so tough to pin down.
But, you know, buried inside all of this randomness, mathematicians have actually found a trail of clues. These fascinating little patterns that hint at some kind of deep, hidden order, and suggest that, yeah, the conjecture might just be true.
So one of the most amazing clues is that these number sequences follow a pattern called Benford's law. Now, this law shows up all over the place in the real world, and it basically predicts how often certain digits appear in the first position. And guess what? The Collatz sequences follow it perfectly. About 30% of all the numbers in these paths start with a 1, just like the law says they should. It's a huge hint that this isn't just random noise.
Okay, but wait a minute. You might be thinking, shouldn't these numbers just fly off to infinity? I mean, you're multiplying by 3, but you're only dividing by 2. It feels like they should get bigger on average. And that's a great question. So why don't they?
Well, here's the little trick. Every single time you use the odd rule, multiplying by 3 and adding 1, the answer is always an even number. Think about it. An odd times an odd is odd. An odd plus 1 is even. So that means the very next step has to be the even rule. You're guaranteed a division by 2. You can never have two odd steps back to back.
So, because you always get at least one division by 2 right after a multiplication by 3, the overall trend is actually downwards. When you average it all out, it's like each odd number is being multiplied by about 3/4 to get to the next odd number. And since that's less than 1, there's this powerful sort of statistical gravity that's always pulling the numbers back down toward 1.
Okay, so this statistical evidence, plus an absolutely insane amount of computing power, has let mathematicians get, well, incredibly close to actually solving this thing once and for all.
And we're not just talking theory here. Using pure brute force computing, we have checked every single number up to 2 to the power of 68. That is an unbelievably huge number. It's almost 300 quintillion. And every single one of them, every last one, has eventually fallen into that 4-2-1 loop. The evidence is just overwhelming. And the progress on the theory side has been just as mind-blowing. For decades, mathematicians have been proving that almost all numbers do what they're supposed to do. But the biggest leap forward came in 2019,
when the legendary mathematician Terry Tao proved that for almost all numbers, their hailstone path will eventually drop below any line you can draw, no matter how low it is.
And, Terry Tao himself said it best. His proof is an incredible achievement. It basically confirms the conjecture for all practical purposes. But almost all isn't the same as all. That final, absolute 100% proof is still just out of our grasp.
So, if we've checked 300 quintillion numbers and we have a proof that it works for almost all of them, why can't we just call it a day? Why is the case still open? Well, let's look at the doubts that keep this whole mystery alive.
For this entire idea to be wrong, one of two things has to be out there hiding in the wilderness of numbers. These are the two rogue scenarios that mathematicians are always on the lookout for.
So, the first possibility is what you might call an escapee, a number sequence that somehow defies that statistical gravity we talked about and just keeps going up and up and up forever. The other possibility is a hidden loop, like a totally separate island of numbers cycling amongst themselves, completely cut off from our 4-2-1 loop. So far, nobody's found either one.
But here's the cautionary tale. This is why checking quintillions of numbers just isn't enough. There's this other famous problem, the Collatz Conjecture, that seemed to be true for an astronomical number of cases, far, far more than we've checked for Collatz. And yet, eventually, someone found a single gigantic counterexample that proved the whole thing was false.
And that leads us to maybe the deepest, most mind-bending possibility of all. See, in math, some questions are what's called undecidable. That means it's logically impossible to ever prove them true or false using our current system of logic. The Collatz Conjecture, it could be one of them. We might be searching for an answer that just doesn't exist.
And maybe that's the ultimate takeaway from this whole thing. It's a quote from one of the greatest mathematicians ever, Paul Erdos. It's this humble reminder that even with the simplest rules imaginable, we can ask questions so profound they show us just how much we still have to learn, and that we are really just scratching the surface of the wild and beautiful nature of numbers.